In this lesson, we will examine how to tackle work questions. These questions include situations such as machines making products, people mowing the lawn, and pumps emptying pools, to name a few. In general, work problems feature someone or something generating some sort of output. The nice thing about work problems is that we can solve them by taking these familiar formulas and modifying them slightly. Now, as you will see, work problems are very similar to motion problems. Both have elements of time and rate, except in motion problems, when rate and time combine, the result is distance, and with work problems, the result is some sort of output. To see the similarities between these formulas, let's look at some examples. First, if a car travels at a rate of 30 miles per hour for 5 hours, then the distance traveled will equal the rate of 30 miles per hour multiplied by the time of 5 hours to get a distance of 150 miles. Compare this to a situation where a certain machine makes widgets at a rate of 30 widgets per hour. If the machine operates for 5 hours, then the total output will equal the rate of 30 widgets per hour multiplied by the time of 5 hours to get an output of 150 widgets. Now consider these two situations. First, if a meteor is traveling at a rate of 10 kilometers per second, we can calculate the time for it to travel 800 kilometers by taking the distance of 800 kilometers and dividing it by the speed of 10 kilometers per second to get a time of 80 seconds. Compare this to a situation where a machine can produce toys at a rate of 10 toys per second. To calculate the time for the machine to make 800 toys, we will take the desired output of 800 toys and divide it by the production rate of 10 toys per second to see that it will take 80 seconds to produce 800 toys. Now let's apply these concepts to a question. Here a machine can produce 75 pencils in 5 minutes, and we want to determine the time it will take for the machine to produce 900 pencils. To do this, we will need to apply the time formula. Now we know the desired output is 900 pencils, but we still need to find the rate of production. To calculate this, we will use the rate formula. Now the question tells us that the machine produces 75 pencils in 5 minutes. So to find the rate here, we will take the output of 75 pencils and divide it by the time of 5 minutes. When we do this, we get a rate of 15 pencils per minute. Now that we know the machine's rate of production, we can calculate the time it will take to produce 900 pencils. This will equal the desired output of 900 pencils divided by the rate of 15 pencils per minute. When we evaluate this, we get 60. But what are the appropriate units of time here? Well, since the rate is measured in pencils per minute, the resulting time will be measured in minutes. So the machine can produce 900 pencils in 60 minutes. Now please note that many work problems are easily solved using ratios as well. Let's see how. In this question, we are comparing the number of pencils produced to the number of minutes it takes to make them. The question tells us that for every 75 pencils made, 5 minutes elapses. Assuming that the rate of production remains the same, this ratio will equal the ratio of 900 pencils to some unknown time, m. To solve this equation for m, we can first simplify the ratio on the left-hand side, and then cross-multiply. We can now simplify the right-hand side, and then divide both sides by 15 to get a time of 60 minutes. So using equivalent ratios, we can see that it will take the machine 60 minutes to produce 900 pencils. Okay, now let's try another question. Here we are told that it takes Rama 6 days to paint a certain house, and it takes Trudy 12 days to paint the same house. We want to determine how many days it will take them to paint the house if they work together. To begin, let's determine the output rate for each person. To do this, we will apply the rate formula, which tells us the output rate is equal to the output divided by the time. Now the question tells us that Rama can paint one entire house in 6 days. So to find Rama's output rate, we will take the output of one painted house and divide it by the time of 6 days to get an output rate of 1/6 houses per day. In other words, Rama can paint 1/6 of a house each day. Similarly, if Trudy can paint one house in 12 days, then to find her output rate, we will take her output of one painted house and divide it by her time of 12 days to get an output rate of 1/12 houses per day. In other words, Trudy can paint 1/12 of a house each day. Now we want to determine how long it will take Rama and Trudy to paint the house if they work together. To do this, we must first find their combined output rate. This will equal Rama's output rate plus Trudy's output rate. Let's go over here to add these two rates. First, we will write them with common denominators, then add the numerators, and then simplify this to get a combined rate of 1/4 houses per day. Now that we have the combined output rate for Rama and Trudy working together, we can apply the time formula to determine how long it will take them to paint the entire house. Now the desired output is to paint the entire house, so the output is one painted house. We will divide this by the combined output rate of 1/4 houses per day. When we do this, we see that it will take Rama and Trudy 4 days to paint the house. Okay, let's try one more question. Here we are told that pump A can empty a certain pool in 40 minutes, and working together, pumps A and B can empty the pool in 24 minutes. We want to determine how many minutes it will take pump B to empty the pool on its own. To do this, let's let B equal the number of minutes it takes pump B to empty the pool. Now, as always, we will begin by determining the output rates of each person or machine. As such, we will need to use the rate formula. Beginning with pump A, we are told that it can empty the pool in 40 minutes. To determine pump A's output rate, we will take the output of one emptied pool and divide it by its time of 40 minutes to get an output rate of 1/40th of a pool per minute. Next, we will find pump B's output rate. To find pump B's output rate, we will use the fact that pump B can empty the pool in B minutes. So to find the output rate here, we will take the output of one emptied pool and divide it by a time of B minutes to get the following output rate. Finally, let's examine the combined output rate of the two pumps working together. We are told that working together, the pumps can empty the pool in 24 minutes. So their combined output rate will be one pool divided by 24 minutes, which gives us 1/24th of a pool per minute. Now that we have the individual and combined output rates, we can write an equation. We can say that the output rate of pump A plus the output rate of pump B must equal the combined output rate. At this point, we have an equation we can solve for B. First, we can isolate B by subtracting 1/40th from both sides. Then we can rewrite these fractions with common denominators and then subtract them. Once we simplify the fraction on the right-hand side, we could cross-multiply, or we could recognize that if 1 over b is equal to 1 over 60, then b must equal 60. So working alone, pump B can empty the pool in 60 minutes. Alright, let's summarize. In this lesson, we learned 3 formulas related to work. We learned that when solving work problems, we should typically begin by finding the output rates of all machines or workers involved, and we learned that we should add output rates when there are 2 or more people or machines working together. In this video, we will examine a technique often referred to as the double matrix method. This technique can be used to solve questions involving populations where each member of the population has 2 features associated with it. Now in this question, we have a population of vehicles, and each vehicle has exactly 2 features. The 2 features are the vehicle's color, red or green, and the vehicle's type, car or truck. Now we can also tackle these types of questions using Venn diagrams, but I believe that the double matrix method is particularly effective for solving upper-level questions. Here's how the method works. We're going to take each of the 80 vehicles and place them into one of the 4 boxes shown here. Now one of our 2 features is vehicle type. So in the 2 boxes in the top row, we'll place cars, and in the 2 boxes in the bottom row, we'll place trucks. The other feature is color. So in the 2 boxes in the left-hand column, we'll place red vehicles, And in the two boxes in the right-hand column, we'll place green vehicles. Our ultimate goal will be to place each of our 80 vehicles in one of the four boxes, depending on the vehicle's characteristics. So in this box, we'll place red cars. In this box, we'll place green cars. In this box, we'll place red trucks. And in this box, we will place green trucks. Now the question asks us to find the number of red cars. So let's add this asterisk in this box to remind us of our goal. Alright, it's time to start adding information. First, we are told that 35 of the vehicles are red. Now some of those red vehicles will be red cars, and some of those red vehicles will be red trucks. At the moment, we don't have enough information to place any of the 35 red vehicles in either of the two boxes. However, since 35 of the vehicles are red, we know that the sum of these two boxes will be 35. So let's add this here. We now know that the numbers in the two yellow boxes must add to 35. Now, if there are 80 vehicles altogether, and 35 of them are red, then we can conclude that the remaining 45 vehicles must be green. Now, some of these green vehicles will be green cars, and some will be green trucks. So we cannot place any number into either of these two boxes. However, we do know that the sum of these two boxes must be 45. Next, we are told that 60 of the vehicles are cars. Now, some of these 60 cars are red cars and some are green cars, so we can't place any of the cars in either of the two individual boxes. However, we do know that the sum of these two boxes must be 60 since we have 60 cars altogether. Now, if there are 80 vehicles in the parking lot and 60 of them are cars, then the remaining 20 vehicles must be trucks. So the sum of these two boxes must be 20. At this point, we don't have any information about the number of vehicles to be placed in each of our four individual boxes. We only know the sums of the boxes in each row and each column. To fill in each box, we need a seed, and here it is. We are told that there are 9 green trucks. Since this box is reserved for green trucks, we can add 9 to this box. Now that we know the value of one box, we can complete the rest of the table. For example, we already know that the sum of these two boxes must be 20. Since one box is 9, the other box must be 11. We also know that the sum of these two boxes must be 45, so the top box must be 36. Finally, we know that the sum of these two boxes must be 60, and since one box is 36, the other box must be 24. So, of the 80 vehicles in the parking lot, there are 36 green cars, 9 green trucks, 11 red trucks, and 24 red cars. The question asks us to find the total number of red cars, so it's 24. As you can see, this method is great for effectively organizing information, and this will come in handy when you tackle more advanced questions.